Got a quick problem for you today. Find all triples, A, B, and C, that are integers that make up a right triangle such that the area of the triangle is equal to 5 times the perimeter of the triangle. Okay, try it on your own and let me know in the comments if you're able to solve it, or you can just watch me solve it. Okay, so the first thing we should know is we have a right triangle. So our friend Pythagorean told us that the hypotenuse is equal to the square root of the sum of the squares of the two legs. Right, that's the Pythagorean theorem. So what is the area? The area is 1/2 base times height. So 1/2 AB is equal to 5 times the perimeter. So that's 5A plus 5B plus 5 square root of A squared plus B squared. Okay, and now let's bring everything over to the left except for this last term, because then we're going to square both sides. And let's multiply each side by 2 while we're at it. So AB minus 10A minus 10B is equal to 10 square root of A squared plus B squared. Right, and now let's square both sides. And then we're going to look for integer solutions of what we're left with. So when we square this left-hand side, it's a little bit messy. So let's write it out. A squared B squared minus 10 A squared B minus 10 AB squared. So that's multiplying AB times all of these terms. Now we have to do negative 10A times all the terms. So minus 10A squared B plus 100 A squared plus 100, AB. And now multiplying negative 10B to each of these terms, we get minus 10 AB squared plus 100 AB plus 100B squared. So this is the left-hand side multiplied out, and it's equal to the right-hand side, which is 100 times A squared plus B squared. Okay, cleaning this up and bringing everything to one side, we have A squared B squared minus 20 A squared B minus 20 AB squared plus 200 AB is equal to 0. Okay? And now notice each term in this left-hand side has an AB in it. But A times B, we're going to assume both A and B are positive since they're lengths of triangles. So we could divide out by AB. So our equation is AB minus 20A minus 20B plus 200 is equal to 0. And so how do we find integer solutions to this? Well, we could try to factor this. Right? This looks very similar to A minus 20 times B minus 20. Right? But if we multiply this out, we would get AB minus 20A minus 20B plus 400. So let's subtract off 200 equals 0. And now let's just add that 200 to the right-hand side. So we want to find basically the factors of 200. It could be 1 and 200. And remember, we assume that A is less than or equal to B. So if A minus 20 is 1, then we have A is equal to 21, B is equal to 220, and then just with a little bit of algebra, you could see C is equal to 221. Okay, so that's one of our triples. It could be the case that the factors are 2 times 100. So then we have A equals 22, B equals 120, and C is equal to 122. Okay, and you can see we're going to do this for each of the factors. So we could have 4 times 50, and that gives us A equals 24, B equals 70, and C is equal to 74. Right? How am I getting C? Well, I did the algebra off camera, but it's just the square root of A squared plus B squared. Okay, so if you're not sure where C is coming from, it's just the square root of A squared plus B squared. Okay, we could have 5 times 40, which gives A equals 25, B equals 60, and C is equal to 65. Okay, there's only a couple more. We could have 8 times 25, which gives A equals 28, B equals 45, and C is equal to 53. And then last, we could have 10 times 20, which gives A equals 30, B equals 40, and C equals 50. Okay, so not a really tough one today, but I thought it was a pretty neat question. Let me know if you're able to solve it, and if you like questions like this, I'm happy to make more videos. Well, thanks for watching, and let me know in the comments if you made it to the end of the video. I really appreciate those of you who make it all the way to the end. All right, bye-bye.